given events A and B. Conditional probability is the probability of an event B occurring, knowing that event A has already happened.
Come on, guys, put some phones away, get your notes out, take some pictures.
Okay, already occurred. Page 30.
Page 30.
It's cut off at the top here. Just look for conditional probability. All right. We have notation for this. The probability of B with a line, vertical line. I like putting mine on a little bit of a slant, but most of the times you'll see it as a vertical line. It's red. The probability of B given A. And we do have a formula for this. Probability of B given A equals the probability of A and B divided by the probability of A. Okay. So then I went to proceed using the formula. Now, by the time we're done, you guys probably aren't going to use a formula. You're probably going to just try to reason these things out, which is a whole lot easier, right? Okay, so let's use a formula on the first couple. It says Mitchell drew a card from a standard deck of playing cards. So how many total cards do we have in a deck of cards?
52.
52, right? Okay. What is the probability that he drew a queen given that the card was red? So here's our A, right? Given that the card was red. How many red cards do we have in the deck? Yeah, that's our A, 26. And our B then is drew a queen. And how many queens are there in the deck of cards? 4, right? Okay, so there's our numbers. So all we have to do is just plug it in our formula and bam, we'll get our probability. Remember, it's got to come out of fraction. Probabilities come out of fraction. So I need the probability of A and B. So I'm going to do what? Multiply these, right? Probability of A and B, you multiply. So I'm going to have probability of A is 26 out of 52 times 4 out of 52, all divided by the probability of A is our 26 divided by 52. Isn't this fun? All these fractions, dividing fractions. You're going to need to put parentheses when you put this in a calculator around the numerator and the denominator. Okay, you ready? Everybody got their calculators? Going to punch the numbers in with me? Of course you do. All right, parentheses. 26 divided by 52 times 4 divided by 52, parenthesis, divide by, parenthesis, 26 divided by 52, parenthesis, hit enter, and then hit math, enter, enter, and I get 113. Now, I'm going to teach this now. Okay. You could use a formula, but you can kind of reason this out, right? Think about this just for a sec. Let's just use common sense here. Okay. I know it's maybe hard for a few of you. Um, the probability that he drew a queen, given the card was red. Well, how many red cards are there in the deck of cards? And how many red queens? Two. Look at that. 113. So it's up to you which way you want to do this. When we get into some work, I was doing some homework problems with my other class. It got real wordy, and it was kind of hard to do the formula because you didn't know exactly what the probability A was or B. And if you just reason it out, it's almost easier than putting it into the formula. But if you want to use a formula, that's fine. Number two, a number from 1 to 100 is randomly selected. Okay. What is the probability that it is a perfect square given that it is an odd number? Okay, so my A here again is an odd number. How many odd numbers do I have between 100 and 1 and 100? 50, right? Yeah, half of them are odd. Okay, and now I have to think about the perfect square, right? That's my B. 10, yeah, right. 10 squared is 100, so you have 10 perfect squares, right? So that's my B. I have 10 perfect squares. Now, we can plug this all into the formula, chug it out here. I have probability of A and B. So the probability of A is 50 out of 100, right? 50 odd numbers out of 100 times the probability to B, which is 10 numbers out of 100, divided by the probability of A, which was 50 divided by 100. And I could plug all this into my calculator. And we get 50 divided by 100 times 10 divided by 100 divided by 50 divided by 100. Enter, math, enter, enter, and I get 1/10. Okay, so let's try to reason this through. An odd number, okay, given that it's an odd number, it's my 50, right? So this is my second way of doing this. I have an odd number, so that's 50 numbers. And a perfect square, now how many of them are going to be odd? Of the 10 perfect squares I have, how many are going to be odd? 5, because there's 5 odd numbers, right? 5/50 reduces to 1/10. Again, you can use a formula. Sometimes it's a lot easier just to reason this out. Now, on your SATs, they're going to have what's called Venn diagrams, right? It's going to be usually a couple of them, I think. If not, there's going to be at least one. Does anybody know what Venn diagrams are? Well, they're going to be usually they're two intersecting circles. Okay, and it visually helps us organized data. Okay. In other words, let's read the problem. There are 62 people that take yoga class and 48 people that take spinning class. I guess spinning is a bike thing, right? Unless they're my other classes are like fooling me. So I have a yoga circle and I have a spinning circle. And I'm just going to put my totals here just to help me out. So yoga I had 62 people and 48 people for the spinning. All right, let's go. Let's continue on. 15 people that take yoga also take spinning. So that's going to be my intersection here, the two circles, because they're taking both, right? So I've got that 15 here. My 15 goes here. And for my yoga people that do not take both, I'm going to take that 62 minus the 15. It's going to give me, let's see, 47. That leaves 47 people left for yoga. And 48 minus 15 is going to be 33. Okay. So if a person from these groups is selected at random, find the probability that he or she takes yoga class if you know they take a spinning class. So they want that intersection yoga and take a spinning, right? There's my 15. And now they're going to want to know if they took, if you know they took the spinning class. How many people take the spinning class? 48, right? So we just reason this out. I don't know. Yeah, this can be reduced. 3 goes into 15, 5. 3 goes into 48, 16. So I'm done. You see how Venn diagrams organizes our information to find what we're looking for? All right, let's do another one. Okay, of the 30 students in Mrs. Smith's math class, 13 are athletes. So I have an athlete circle. And I'm just going to put the total here 13. And 9 are in the band. So I need a band circle. Band circle. And I have 9 of those. 3 of the athletes are also in the band. So there's my intersection, right? 3 of the athletes are also in the band, which leaves us how many athletes without being in the band? 13 minus 3, 10. And then band members that are not athletes, 9 minus 3 is 6. Okay, so let's figure out what they want. If one student is chosen at random, find the probability that this student is in a band. So, how many students in the band? And that are not an athlete. So, students in a band, not an athlete, it's going to be 6, right? Just 6 out here. Can't include these 3 because they're in an athlete. So, it's going to be 6. And now you got to be careful here because it said chosen at random, right? Chosen at random. That means I have to go back and include the whole 30. So I'm going to have my 30 and it is not an athlete, so I have to minus the 13 athletes. Okay, so I end up with 6/17, and that's my answer. Okay. Two-way tables. These are not that difficult, guys. The easiest way to do these: add up your rows and add up your columns. Um, to add up the rows, go across. 18 plus 6 is 24. 10 plus 16 is 26. 18 plus 10 is 28. 6 plus 16 is 22 for my columns. And also, these should equal each other, right? 24 plus 26 is 50. 28 plus 22 is 50. This is my total that they did, right? Let's go back and read what they want. The table shows the result of a poll of 50 randomly selected students who were asked whether they preferred to watch hockey or football. Find each probability. Again, we're going to reason these through because I have all the data on the table, just like we had the data on the Venn diagrams, right? Okay. Let's see. My probability is girls. How many total girls do I have? Total girls, 22. And of those 22, prefer football, 6. Reduce, 2 goes into 6 3 times, 2 goes into 22 11 times. Okay, next one. Hockey. So I need the total for hockey, which is 26. That's my A, goes on the bottom. And the boys who like hockey, 10. Boys hockey is 10. Reduce, 5/13. Seems easy enough, right? All right, some more tables. Let's get our totals. 19 and 23 is 30, 42. 25 and 12 is 37. 38 and 33, 60, 71. 1925 is 30, 44, 70, 82. 23, 35, um, 35, 35, 35, 35, 68. Is that right? Okay, 150, right, is our total. Now I can, now I can probably explain everything that you want. Ready? A seventh grader who takes French. So here's seventh grader that takes French is 25. What am I going to use for denominator? Seventh grader that takes French. What's the probability of a seventh grader who takes French? 25 out of 150, right? Okay, this can be reduced. How many quarters in a buck and a half? 6. Okay, B is not going to be so easy because it got the given signs, right? Let's see, we're looking at take Spanish. So Spanish is going to be 68. And an eighth grader that takes Spanish is 33. And that cannot be reduced. Okay, given a sixth grader, Total sixth graders, 42. And sixth graders that take French, 19. See how much easier it is when you have the totals there? Takes French. So I need French is 82. And seventh grader that takes French, 25. And does this reduce? Five. Nope. That's it. Last one. Because we're not doing frequencies. No, we're not going to go there. Nope, 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 nope. Six. I'm going to add them up. 28, 97, 11, 13, 125. 56, 75. So that gives me a total of 200. Let's see, 84, 16, 116. Okay, so we have a total of 200. What's the probability of a junior that did not attend prom? Junior, no prom, 56. And we're randomly selecting, and we have 200. They're both even, so we can definitely reduce by 2. 28 over 100, still reduce, right? 7/25. Okay, B. Given senior, so how many seniors do we have? 116. It's my probability, but it goes on bound. Given senior did not attend prom, so I need 75. Oh, sorry, seniors 19 that didn't attend, so 19 over 116. Can this be reduced? Nope. And the last one, yay, attended prom. So we're looking at proms. Yes, is 125. My denominator. Junior that attended prom, 28. And this is this going to reduce? Yeah. No. No. Nope. So I'm done. You guys can do your homework now. Aren't you excited about that? So do page 33 and 34. Um, Let me do the first one. Okay, and you're more than happy to use the formula, but I'm going to try to do reason because I already got enough work to do here. Because I have to figure out from 50 lottery balls what are the multiples of 6. So multiples of 6 here. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. And everything else is going to be bigger than 50. Okay, two-digit numbers is going to be, um, let's see, it's going to be 10 on, right? So two digits, I'm going to be, there should be 40, including the number 10. So it's actually 41. And if you don't believe me, you can count them. Okay. So I'm going to have the probability of A is my 41, right? So my probability denominator is 41. Now be careful here. I need the multiples of 6,
Okay.
but they have to be two-digit numbers.
So
7. Now it took me like 2 times to get this right when using the formula. At this point, the formula is more confusing than trying to reason it out. 3. Marty rolls 2 die. What is the probability that the sum of the die is 7, given the first die is showing a 2?
was it 2 over, or no, 1 over 6 times 1
1,
over 6?
1 over 6.
Just 1 over 6?
Yeah. Okay, because you've got, given that this is my A, right? One out of 6. Um, and then the sum of the die is 7.
Oh, it's so.
Yeah.
So it's saying, I don't know why I thought it was saying that the first die, or the second dice is rolled a 7.
Let's see. There's 1, 6 and 1, 2, 2 and 5. Three and 4, 5 and 2 we already have. So 3 out of 12, right? So if you're doing it with the formula, you would have to do the 3 out of 12, or 1/4, times, given that the first die is showing a 2, it's, the probability of A is, uh, 3 out of 2, 1/4. It's a lot easier just to reason it out. At least 20. We're back to the lottery balls, right? At least 20. So 20 to 50 is 30. Or is it 31? 20. I did this on my last hour.
Subtract those, so yeah, it would be 21.
21, right? So this is 21. And a prime number?
Out of 1 through 50,
Yep.
25.
Ooh, no, we better count them, right? Let's see. Prime numbers,
Prime numbers.
1 to 50. We got 2, 3, 5, 7, 11, 13, 17, 19, 23, 27, 29, 31, 33, 37, 39, 41, 43, and 47. Okay, let's do the shortcut. Let's just reason this out. At least 20. So these we're not going to count, right? Because they have to be at least 20. And a prime number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's our total though? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, this is not. 33, 37, 41, 43, and 47, right? Did I screw up any others? 27, 33. Wow. Nice job, Mr. D. Okay. Does that look right? All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. My total is 15. Okay. And at least 20. So 1, 2, 3, 4, 5, 6, 7, 15s. Much better. 15 prime numbers and 7 are at least 20. Sure. How about I'm going to do number 10. Just got to keep going here because this is so much fun for me. I'm going to do my little diagram here again. Okay, 125 children at a summer camp. 45 signed up for swimming. So I need a swimmers circle. And 45 signed up, right? And then I've got a arts and crafts. And 38 signed up for those. Okay. 12 students signed up for swimming, also signed up for arts and crafts. So 12 is going to be my intersection, right? Okay. So swimmers without arts and crafts, 45 minus 12 is going to be 33. Where's my purple? No, there it is. 33. And arts and crafts minus my 12 swimmers. It's going to be 28 minus 2 is 6. 26. Okay, do I have everything? It looks like it. What is the probability they are signed up for swimming if it is known that they did not sign up for arts and crafts? Okay. So it's going to be they did not sign up for arts and crafts. It's 33 for my swimmers, right? That did not sign up for arts and crafts. And then what is the probability that are signed up for swimming? Total for swimming um, is going to be calculator. Don't want to screw this up. Okay, so it's going to be my total children. I got to write it out. Okay, my total was 125, I'm going to subtract. Let's see, you probably signed up for swimming. So I'm going to subtract the arts and crafts because they want the total for swimming. So that's going to equal 33 over 87. There you go. Wasn't that fun? Oh, don't do number 14. That's one of them, their frequency things. Okay? All right, have at it.